Welcome back to the deep dive. Today we are tackling one of the most persistent bottlenecks in modern software creation. It's that chasm between a beautiful, visually complete vision and a secure, functional product. We're diving deep into what we've dubbed vibe coding, that electrifying high-speed rush of just designing something.
And that vibe is such a powerful thing. I mean, vibe coding is when you use these incredible design-focused tools like Lovable. You can literally spend an afternoon and produce a user interface, a UI that looks like it just came out of a polished, multi-million-dollar pitch deck. It captures the feeling of a finished product.
The
Instantly.
feeling is intoxicating. You hit that moment of pure satisfaction, right? You're thinking the hard part is over. I'm basically ready to launch.
Oh, yeah.
But you and I both know that is precisely the moment the real difficult and often soul-crushing work begins. So our mission today is pretty clear from the sources. We need to analyze this precise automated process. How do you convert that visually stunning non-functional design, that perfect vibe, into a fully secure database-connected application, and do it without falling into that traditional trap of writing endless, dense technical code specs?
The traditional trap is it's a universal moment of frustration.
Yeah.
Every solo founder, every creative developer, they all hit it. The prototype is gorgeous.
Stunning.
But it is invariably a pure facade. It's a ghost town under the hood. It lacks the engine, the memory, and the security systems that make it usable in the real world. This is the moment when enthusiasm typically just dies. Because you realize you need to stop everything, hire a full-stack engineering team, and spend like 3 months setting up all the unsexy plumbing.
Okay, let's unpack this journey, starting with the initial allure of that prototype paradox itself. The sources use a specific example of a design called Planner Pro.
Yeah, and if you look at Planner Pro, I mean, it is visually enterprise grade. It has that professional polish. Dashboards, client lists, project tracking, side navigation. All the visual cues of complex, polished SaaS software. You could show this to an early customer or, an investor, and they would be seriously impressed by the speed and quality of the visual execution.
It's a testament to the power of vibe coding. It
Yeah.
makes the promise feel so imminent.
But here's the reality check, right? The inherent paradox of vibe coding. You start tapping the navigation links that look so functional. Meetings, analytics, and what do you get?
Nothing.
A beautiful centered message saying, coming soon. Or maybe the button just does nothing at all. It's the ultimate digital dead end.
That's digital heartbreak because you realize all that time you spent creating the visuals, it's only brought you to the edge of the real problem.
And that problem is foundational. We are missing the 3 critical elements of actual software. First, no database. That means no memory. The application forgets everything the second you refresh the page.
Right.
Second, no login. So zero security or user protection. And third, and this is the critical one, zero backend logic. So even if you could visually save a client name, the application wouldn't know how to query that data or run calculations on it or manage relationships between, projects and meetings.
So we have a perfectly styled shell, a truly excellent design asset, but it has no nervous system to respond to input, and crucially, it has zero financial value until that backend is built. That gap traditionally necessitates an immediate, painful shift from creative, high-speed design work to tedious, expensive, low-level engineering work. That shift is what kills projects.
And that realization, that gap, is precisely what the tools in our sources aim to bridge. The first crucial step is breaking away from the design tool itself. Because you cannot build a complex production application if the design is locked away in a proprietary ecosystem.
That's the vendor lock-in we constantly struggle with. You build something beautiful and feel like you own it, but the moment you need to export the functionality, the design tool just holds the underlying code hostage.
Precisely. That's why the introduction of the Lovable project downloader is so strategically critical. It's a simple Chrome extension, but its function is massive. It breaks the lock-in. It lets the user extract the pure HTML, CSS, and structural JavaScript and the static design blueprint into a tangible asset they truly own.
Okay, so that's step one, taking ownership. We use the extension click download project as ZIP. Now we physically have the front-end code in a file, that visual blueprint we've labored over. What's the next mechanical step to transition this static ZIP file into a dynamic application?
Well, we moved the blueprint to the intelligence platform, Avery. Avery is not just another development environment. It is the virtual engineer we are now hiring to analyze, understand, and inject life into that shell.
And the migration needs to feel frictionless. Otherwise, we've just traded one technical hurdle for another.
And it is. It's entirely frictionless. You start a new application project inside Avery, and instead of choosing Start from Scratch, you select Migrate Codebase. You take that entire ZIP file from Lovable, and you just drop it in. Avery immediately ingests the visual structure, the navigation, the forms, the placeholder pages.
So Avery is looking at the entire file structure of Planner Pro, all the buttons, all the ghost pages, and preparing to give it intelligence. It's essentially reading the user's design intention.
It's mapping the design structure to potential data models and functionality. It sees a visually defined form labeled Add Client and immediately understands the intent of that form. It knows the user intends to create a new record, even though mechanically the form currently does absolutely nothing. This visual interpretation is key.
This transition from dropping a static file to actually instructing the system is the pivot point where we replace months of traditional development work. Instead of writing a 100-page system requirements specification, we're just communicating with the system.
The novelty here is that conversational approach. The experience is described as feeling like you're texting a developer. You're moving away from formal technical documentation toward high-level, business goal-oriented instructions.
That translation process, turning what the business wants into what the code needs, is where most projects lose velocity and budget. You have to specify every single field, every data validation rule, every endpoint.
Precisely. That formality is just eliminated. Here, the user simply looks at the imported design and communicates the deficiencies they need fixed. The instructions given in the case study were beautifully simple. See those buttons, make them work. Connect to database. And the critical one, addressing the dead ends. Build those empty analytics pages for real.
That instruction, build those empty analytics pages for real, is truly asking the system to invent complexity based purely on context. But let's look under the hood. What is Avery actually doing when it receives those 3 simple instructions?
Avery becomes the heavy lifter. First, based on the design context seeing forms, client lists, project fields, it infers the necessary data structure. It automatically writes the database schema, defining the fields, data types, and critical relationships between tables. This typically requires a specialized database architect.
And the schema is the absolute backbone, the rules for how the data will be organized and stored permanently. That's very detail-oriented work where a single mistake can break the entire application later on.
Absolutely. But Avery doesn't stop at the database. To allow the application to interact safely with that data, you need secure API endpoints. Avery automatically generates and secures these invisible pathways, the routes that allow the front end to safely communicate with the database without exposing the entire system to public scrutiny.
Wait, I have to introduce some friction here. This is amazing speed, but how do we know the code Avery is generating for these endpoints is clean and scalable? Aren't we just moving the problem of technical debt from a human developer to a virtual one?
That's a crucial question. The sources emphasize that the code is optimized for production standards because the platform's core mandate is structural integrity and security. Furthermore, Avery automates state management. This is how the application keeps track of what the user is doing, filling out a form, moving between pages, handling errors, without dropping information.
And for anyone who's built a modern web application, state management is often the most confusing and time-consuming part of the whole build. That's where you lose days to debugging.
It is the tedious, repetitive work that usually kills enthusiasm. Avery is automating the architecture, the security layer, and solving the hardest front-end communication problems, all based on interpreting visual structure and conversational intent. It's converting intention into functional, production-ready complexity.
And the proof of life is almost instant. Because the moment Avery finishes processing the migration, which takes minutes, not weeks, the very next time you load the application, you're not seeing the Planner Pro dashboard. You see a login screen.
That's the automatic security kicking in. Avery interprets the need for data protection and immediately enforces it. It builds the full, robust authentication flow. Sign up, log in, managing passwords, session tracking, all the boilerplate security requirements you need before you can even think about deploying an application to the public internet.
And that's work that, for a solo developer, is often dreaded. It has zero creative payoff, but massive security risk if it's done incorrectly.
It is the ultimate utility requirement. But once you log in, the dashboard visually looks exactly like the Lovable prototype. The key word here is looks. Functionally, everything has changed. We need to run the critical test. data persistence.
Let's run the test from the case study. They navigate to the client list and add a new client named John Doe through the applications form.
Okay, so in the original Lovable prototype, you would type in the name, hit save, and you might get a visually satisfying animation. But if you close the browser, logged out, or refresh the page, John Doe was gone. Forever. The data was just faked in the browser window.
But in this Avery migrated version, what happens when the user hits save?
The data is permanent. It is routed through Avery's generated secured API endpoint, written into the newly provisioned database, and immediately reflected in the client list. You refresh the page, you close your laptop, you log in on another device, John Doe is still there. That single moment confirms the transition from a prototype to a functional, persistent production application.
That is the single most important signal that the deep technical work is done. And this persistence feeds directly into the second major triumph, the analytics page.
The page that less than 10 minutes ago in the prototype was just mockingly saying, coming soon.
So now what does it show?
Now, it is displaying and graphing real data. And this is crucial because it demonstrates Avery's ability not just to wire up existing design elements, but to fill in the design gaps. It looked at the structure, saw the data models it created, clients, projects, and so on, and wrote the actual business logic to derive meaningful metrics. It calculated metrics like projects completed last quarter and rendered that data visually, entirely based on the instruction to make the analytics real.
So it created the necessary calculations and visualizations from scratch, based purely on interpreting the intent of what an analytics page for this kind of app should be. That truly defines the role of the virtual engineer.
It's inference applied to software construction. It saves hours of writing calculation logic and setting up charting libraries.
And after all that heavy lifting, the data, the security, the analytics logic, the state management, the final step is deployment.
And that's the easiest step of all. They just hit deploy. Avery handles the secure deployment infrastructure, spinning up the necessary cloud resources, ensuring the database is correctly linked, and making the application live and scalable instantly. You get production quality without needing to worry about the underlying server management.
So what we're looking at here is a brand new paradigm. The fun and visual satisfaction of vibe coding in Lovable no longer leads to an inevitable, soul-crushing bottleneck. It transitions seamlessly into a stable, secure production application courtesy of Avery.
The overall benefit is the strategic elimination of the biggest bottleneck, the need to hire a senior developer or a CTO immediately after the design phase. You can take a visually complete design and, using conversational instructions, turn it into production software that is functional, secure, and ready to scale.
It fundamentally changes who can launch complex, data-driven software. It takes what used to require an engineering team and makes it accessible to a single creator, allowing them to focus on market validation and feature refinement rather than spending months on the plumbing.
The focus shifts entirely from writing boilerplate code to defining outcomes and business logic.
It's a remarkable loop. Design intention converted into functional code, with the platform filling in necessary logic gaps, like that analytics page, based purely on context. It's automation doing truly creative, interpretive work.
It is, and it really highlights how quickly the definition of fundamental technical expertise is changing.
Which brings us to our final thought for you to explore as you consider your next project. We've seen a virtual engineer successfully interpret design context and conversational instructions to write complex logic-building authentication, calculating analytics, managing state. If that level of interpretive automation is possible today, writing the functional plumbing of an application, what is the next higher layer of complexity, maybe high-level strategic data modeling or complex multi-system architecture that will be fully automated and generated next year?
The question shifts from what can be coded to what can be intended.
We hope this deep dive gave you the shortcuts and the strategic insights you needed. We'll catch you next time.